We were working in section 2.2 last time, and we had left off talking about some graphing issues. So let's just kind of pick back up with the graphs where we were. We had talked about the way in which we can take a graph, and we can draw a graph that would represent its slope graph, its derivative graph at every point. And we had done this by identifying a few specific points, talking about where things had slopes of 0, had slopes that were positive or negative, and if on some of them we needed to, talking about how the slopes were changing so that we were able to draw these graphs. And so we had this graph of something on number 3 that looked a little bit like a cubic graph, and it ends up being something that looks a little bit like a parabola. This one looks a little bit like a parabola, and we drew something that may have looked like a line. We talked about having sort of some flexibility in doing that since we didn't have a scale. And we looked at something that was a straight diagonal type line turned into a horizontal line. And then we had this graph, which we talked about the fact that you won't even encounter doing its derivative until you get to calculus 2. And it's a graph of an exponential. And then we had a graph that kind of combined a few of those things in a piecewise function. And then we're going to take a look at this one. All right, so this is the last one we were going to look at. And in this case, what we're going to be given is we're given the details about the graph. And we're asked to sketch the graph of a function that has these details. So that's where we're going to end this particular lesson. So let me draw an axis for us. And the first things we're going to plot is we're going to plot the details about f itself. So these pieces right here at the beginning are actually ordered pairs, right? They're points on the graph. I know that when x equals -2, y equals 2. So we're just going to plot that. X equals -2, y equals 2. I'm about right here. I have the function when x equals 0, I'm supposed to be at y equals 3. And when x equals 4, I should be at y equals 1. So those 3 pieces of information, you have no flexibility in how you draw this graph. They are very definite pieces of information to plot. After that, we have a little bit of flexibility in what's going on, because all we're told information about in the last 2 pieces is what the derivative is doing. So let's take them one at a time. The first one says f prime of -1 is 0. So f prime is talking about the slope. What does it mean for the slope to be 0? What could be happening there? We have some choices. Okay, so it's flat. How do you get something to be flat? So one option is that it's flat out a line on that piece, right? Like a horizontal line. It could be a peak or a valley. Or it could simply do something where it sort of levels off at that one spot, right? So looking at this point at x equals -1, we have some choices. We're not told how it has to be drawn. So let me kind of sketch some different options of how we could draw it. So one option is that simply at this point we're on a flat line, which was one thing you guys had mentioned. Another option is that maybe it's a peak, but that feels a little awkward on this one for it to be a peak. Why? Yeah, it's actually got, if we go over to the x equals 0, at that point when x equals 0, it's higher than where I am right now at x equals -1. So if I'm going to peak right here, I'm going to still have to go back up and do something like this, which I could do, but that feels a little bit awkward. So maybe you want to draw it like a valley, which would be another option. If you draw it like a valley, it sort of already has that swooping up motion on the other side to get up to the next value, so that might be a good choice. You could also draw something that looks like this. Right, where it flattens out there, and then it continues going upwards after that. So this is the last one I drew, so I'm going to leave mine like this, okay? No reason not to. Exactly, it just has to have a slope of 0 at -1. So you have a choice. You can draw a peak there, you can draw a valley there, you can draw leveling off like mine's going to show right now. Or you could draw a straight line, which would be fine too, a horizontal line. Yes, Chancellor?
I don't know why, but I feel like I'm looking at it, I feel like the 0 is at -2.
The 0 is at -2.
Yeah.
Oh! I'm sorry. I had moved it over. I'm sorry, you're right. So I just need to shift. Whoops. There we go. Thank you. You're right. I had sketched that in the wrong place. Perfect. So there's my point. That purple dot right there is representing whatever the y value is there. Yeah, good point. So if I had drawn a valley, it would have actually looked something like this. Right? which may be what you guys draw. Yeah, your choice. Very good point. All right, so here's where mine was. The other piece of information it tells us is that at x equals positive 2, I have a slope that says negative 3. The derivative is negative 3. So what does that tell me has to be happening to my graph? Yeah. Yeah, so the graph has to be going down because the slope's negative. So over here at x equals negative 2, whatever happens at 0, I'm going to have to be coming back down because at 2, I have to have a slope that's decreasing. Not slope that's decreasing, a graph that's decreasing. The slope that's negative. Does that make sense? Now, I'm not terribly concerned about the scale. There's not a real good way to draw this in such a way that we're going to be precisely negative 3 here. That's fine. The fact that it's decreasing, the graph itself, is enough. So this would be a sketch that would work. And your sketch may not look like mine for pieces of it, but there are pieces of it, of course, that do have to, right? So your graph might look something like that. That would fit all the criteria as well. Agreed? Okay. That's our last one in this section.